I'll change maybe the resolution.
Yeah, sure.
Muy buenas. Hey, hey.
Mucha suerte.
Dani.
Encantado.
Encantado. Dani.
This is a water for you.
Okay, thanks.
And finally, you can pick if you want to have like microphone on your shirt or if you want to hold it in your hand.
Mm-hmm. Wait, is that screen?
Yes, I will also pipe it to the other one, so on the boat. Čo? Ja idem potom tu domov.
Mŕtvej?
To není zle, rovno do postele.
Antikrista to je.
Konečne prosím. Halo? Áno? Nie, tam už nie. Hej, no to sú staré. No, áno. Aha. To už neviem, sa iba hlasuje, nie? Aha, možno už hlasuje? Aha, mi sa zdá, že už to nebolo však plné, tak... Aha, tak jo. To sa aj vyzvíja. Aha, jasné, jasné. Hej, hej, no. Ja, to ešte nie. Je taková fleška? Jo. Could you please copy slides to our Slack so we can then push it to the website after?
Is the ODT enough, or should I? So my slides are on ODT, the Open Office format. Should I convert them to PDF?
No, it's fine.
Oh, okay. Just a second.
Are you going to have a demo?
Not really.
Okay.
Just show pictures. I was just trying to make sure this is the right presentation because I have several files for the same name.
Uh-huh. Yeah, okay. Yeah, thanks.
You're welcome.
Do you want to help with mic or?
I don't know.
Yeah, so yeah, there's some switch to.
There should be switch on top. I think
yeah.
it's on mute now. Yeah.
Yeah.
Okay.
Yes. So just feel free to like stick it to your shirt and.
Mm-hmm.
And last thing, I can introduce you. So what do you want me to say?
I don't know. I developed Foreman and I'm now taking care of the Foreman Docker project.
Uh-huh.
Okay. Working on the integration between satellite and Docker. But maybe that's okay.
And
I have it here.
yeah, sure. I was just checking your name so I won't like screw it.
Oh. I guess it's fine like that.
Yeah. Can you show me your name please again? So yeah. It's Lobato Garcia, right?
Uh-huh.
Okay.
Yeah. Is there? Am I going to have like some way of seeing how much time I have left?
Yeah, we'll show you like three posters. It's like 10 minutes, 5 minutes, and all the time.
And you'll be back there?
No, I'll be sitting down here, so I try to wave on you if you want to pay attention.
Easy. Thanks. Yeah, let's wait for 4 minutes.
Okay, so I guess that we can start. Welcome to another talk. Let me give you a brief announcement. There is a board with some proposals for lightning talks. So if you are interested, you can vote for them and then see them in the evening. Let me welcome Lobato Garcia, who is working on Foreman and Docker and integration with satellite. So please go ahead.
Okay, thank you. Okay, thank you so much for coming to my talk. There's so many talks to schedule at the same time, and there's even a workshop that I would like to attend, but it's not going to be possible. So thank you very much. How many people here know what is Foreman or what it does, at least more or less? You haven't had to use it. Can you raise your hand? Okay, it's about maybe 40%, 50%. Good. If you don't, I hope you have been to Ivan Nitsch's talk this morning to learn a little bit about provisioning and configuring your systems with it. You can go to the foreman.org now and see what it is. So basically, it's a lifecycle management tool. We take care of everything from discovering your hosts, provisioning them, whether they're bare metal or virtual and now containers, and we also take care now of possibly one layer app, taking care of services and applications and orchestration, and possibly the same thing with containers. So I'll repeat this after this talk, but if you develop something with Kubernetes support, it doesn't have to be, I know that most of you are probably Red Hat employees, but even if you, it doesn't have to be a Red Hat product or anything. I want to talk with you later, because we're trying to unify perhaps bindings for Ruby and see if we can stop duplicating work in that regard. Okay, so brief introduction. I'll probably skip it. I always give talks right after lunch. I don't know why, but they always schedule it at that time. And during lunch, your blood is diverted from certain places to your stomach, like your brain, for digestion. So and sugary foods trigger insulin release. Insulin triggers tryptophan production, and that gets converted in melatonin, which is the main chemical component that a lot of pills to get to sleep contain. So you get sleepy, and best time ever to give a talk. Very quickly. Foreman, if you didn't know, it's a community product. It started outside of Red Hat, but after a while they decided to sponsor the project and get all of the core developers in. I'll go very quickly over this. And we have some enterprise customers for the upstream product, which is Satellite 6 integrated with Catello and Pulp. So basically provisioning, the lifecycle of machines plus content management. And some other people use the upstream solution. Some of them are listed there. There's even like a page in the wiki where you can see more people who are using it. Anyway, let's dive into it. Okay, so what is the pain that we're trying to solve, more or less? It's in the modern data center or modern system administrators. They have to deal with very different kind of environments. They have to deal from things like bare metal machines, like we said before, virtualization, and these days containers. It is right now, there are no tools actually that allow you to interface with that in having like the same kind of APIs, the same kind of authentication, and so forth. And it might vary a lot, like how you work with your data center. Especially, this is sometimes very critical when it comes to security, because you never know if your physical machines have like the same level of security as your virtual machines. And right now with Docker and security, we'll go over it later in detail. But you've probably seen Dan Walsh's talk. it's a bit of a problem right now. Okay, so managing system, is what I mean here is just managing workloads, virtual machine configurations, physical hosts. It's complicated. We don't really need to keep our system configuration stable. So like we want to say that we work in a model where your machines can come and go. It's, I guess, how most people who are not working with physical machines work these days. Managing configurations is also a complicated part of managing a modern data center. I guess if you're doing it well, your system's configuration is version controlled. So that could be like your playbooks or Puppet manifests, cookbooks, whatever you use. So that's good. Kind of somewhat related to what Joe mentioned before in his atomic presentation. So RPMs are meant to go forward, and rollbacks are kind of an afterthought to that. So it would be good if you could do things like git revert to do some change in your configuration. Okay, let's skip this. So managing containers right now is kind of difficult to do because without external help, there is simply access to the Docker host is access to everything. So if you're giving access to someone else to your Docker host, you're basically allowing that person to remove other people images. You're allowing that person to reboot your containers. You don't want that. And basically, there's like no layer that prevents you from doing any of these. So we're treating, just a big disclaimer, we're treating the Docker container as a lightweight VM of sorts. A lot of people don't do that, and it's probably a bad way of thinking of it. I like more the approach that Dan Walsh said before, that containers are like services in some way. So we do this because a lot of people who use Foreman use it that way, but we're shifting towards, we're trying to get the transition between lightweight VMs equals container to container equal services to our customers or users. So so security and other concepts that I'll mention during this talk can be somewhat different from what you expect. So okay, yeah, we're kind of like going through the old model to the new model, where Kubernetes is kind of the kernel of your data center, and people should not interact with machines directly. Okay, so like we said, pre-configured systems. This means having a machine that will stay there, like let's say an Apache server, getting 10 or 20, depending on your expectations of traffic or whatever. You get some of them on, you keep them on, you maybe keep like some buffer for unexpected traffic or anything like that. It's just slow if you're going to change them. It's something that we expect that we will consider this the past in a few years, I hope. It's also frustrating because it doesn't give you like any freedom to fail without penalty. Containers do. So if you're trying to get your infrastructure to work in them, you more or less already know the pains, like getting your data outside of your compute containers is kind of difficult. Maybe you are tempted to do it to keep them together, but it's like not how Docker is supposed to work. And we're basically going we're creating big containers, like 1 gig images, that are just not supposed to work like that. So in short, this is like every sysadmin trying to install OpenStack by hand in 2010. We hope that it won't be like that anymore. So we want less of that thing. And we want more of this. This is you writing code after you install Packstack. Probably it'll take you like 1 hour until everything is downloaded and the Puppet manifests are applied. So let's focus then on infrastructure instead of tools. You don't want your infrastructure to go crazy because the new intern pushed some changes to some critical machines by mistake, and I was that intern. I broke YAM repo on more than 10,000 machines at the same time because I pushed the wrong Puppet manifest once, and we solved it fairly easy, even though those machines were more or less fetching manifests through Foreman through one Git repository. So we were able to revert that Git commit and got fixed in a really simple way. But I got really nervous because all the systems all the monitoring alerts started to trigger and everything. So how do we do this? This is kind of the 3 tools that Satellite 6 is composed of. We're going to focus only on the first one, but I can talk to you about the second and the third. The first is Foreman. That's what we've been talking about before. It gives your systems like the lifecycle management, and it also tells them what they should do. So if you have a WordPress machine, you can boot a machine and that machine can contact Foreman and say, hey, what am I supposed to do? You're supposed to be a WordPress machine. Then Foreman returns an ENC, which is like a YAML file with all the configuration that the machine is expected to get. If that machine in the future has to change its configuration, then you go to Foreman, change what that machine is supposed to do, and say, hey, you're supposed to be a MySQL node. Okay, then you send the YAML back to the machine, and the machine gets converted into a MySQL node. All right. So just before we get into containers, I know that I'm spending some time in Foreman, but if you don't understand Foreman, maybe you won't understand why is it relevant in the container world. So it has like a unified API for all of these things. So in this, if you want to say trigger the creation of a liver machine, it's quite different from what you do if you do it in OpenStack. They're like different tools. They don't have a unified API. You just go to, in this case, you just have to tell Foreman, hey, I have liver here, I have OpenStack here, create a new host there, and it will do it in. I mean, you'll be able to post the same kind of JSON regardless of the backend. So that's one of the benefits, and basically having a lot of providers, it's having a lot of problems. We're supporting the Docker provider as well, so you're able to create containers in the same way that you would create any other kind of machine. As I said before, this kind of has to deal with the way people are still treating containers like with VMs. We're probably going to change that sooner than later. So it's all that you see there. It's just like mostly based on JSON, mostly based on REST principles, and it's auto-documented. So if you guys go to the foreman.org/API, you'll see a good description of all the commands, and it comes with a CLI if you don't want to. If you don't want to write the actual JSON and HTTP calls yourself. Same goes for provisioning. We give a set of what we call provisioning templates there. So we kind of unify all of that and say, hey, so we have a couple of operating systems. These operating systems are supposed to use this kickstart. These other, CentOS 6 is supposed to use this kickstart, and CentOS 7 is supposed to use this other one. whatever. So what you would do is you go and create a machine, and say I want a Fedora 20 machine, and it will fetch anything that's needed. You want to create a CoreOS machine, then it will get the cloud config. So it's relatively easy way of dealing with your infrastructure without caring about what's going on below that layer. And it's especially useful if you don't want, if you have like, I don't know, tens of users or hundreds of users, and you don't want them to mangle with your infrastructure and touch it directly. In a similar vein, you can have Docker files now, and you can get your containers to be created by giving them a Docker file. It's a simple thing, but it's just like one more step before we add Kubernetes. So in short, it's just like an abstraction for all of this. One big thing that we'll, in like maybe like 6-7 slides, we'll go over how these concepts face and solve some problems that Docker has. So role-based access control is a critical part of Foreman. It basically gives your users the key to your infrastructure. It gives them authentication, which is important, but is relatively easy these days, I guess, to get people to be authenticated against certain compute resources. But the key thing is that it gives you authorization to your resources. So you can, we'll go through the definition of a role very quickly, just to see how you can bring some authorization to Docker, which there's just like no solution. If you give someone access to the host, you're, like I said, given nearly root access to your Docker, well, at least to the Docker-related features of that host. And it's integrated with LDAP, Free API, Active Directory. So normally you might not even have to change anything in your infrastructure to start providing this authorization features to your infrastructure. So roles are normally defined in this way. It works the same thing for Docker. What you define is a resource. A resource can be things like a host. It can be maybe you don't want your users to be able to create a certain kind of operating system. Then you can define a role just to see some kind of operating system. And this translates to something like this. So you can say, hey, so I want my users to be able to view containers, and I want this role also to be able to create containers but not delete them. And so a user with these two permissions would not be able to do much, just create containers in a general sense and view containers in a general sense. It can be more specific, so you can say, so I want I want my user to only be able to view and create containers in the Docker hosts that are in Spain, and I don't want my users to create containers in the Docker host that is in France, so I only give them the view permission. So it can be more comprehensive than that, and it can get really hairy, but essentially it's a framework for giving you this kind of authorization for that. Right now we're hosting reports for several configuration management solutions like Papa, Chef, etc. Salt, right now Salt is really well supported. And we're emailing you host errata about your system. So if there is some vulnerability or something that was released recently in your host's habit, then you should get some emails. If your configuration in some host couldn't be applied for some reason, then you should also get like emails telling you about that. Okay, so how does this how do all of the things that I mentioned relate to Docker? Okay, so for Docker, I think compute resource security is basically key, as I said, because the daemon by itself doesn't give you any. So you can do things like allow your users in certain registries. You might not want your users to be able to create containers from images in the hub, like Dan Walsh said before. It's generally a bad idea to run things in production that you cannot really know for sure that they are secure. You can also get like protection and monitoring of containers, which is not security by itself, but it allows you to monitor how they are. And authorization for registries. So actually, I included this like 2 or 3 days ago. It's straight from Dan Walsh's blog, and I think he posted the link in his previous presentation. But anyway, so this is how people install packages for 10 years. You search the internet for a package, you find the RPM or deb or whatever you use, download the program, install it, and after you install it, you run it with privileges. So you're pretty much letting the person who creates the package do anything that that person wants. Like I said, it's really simple to add any kind of script into a post-install part of a deb package, for instance. So how to handle privileged containers, like how do you make sure that the image in the privileged container is not going to do anything like that? You should probably either, if your host is only going to be used by 1 or 2 or 3 people that you can trust, maybe add that person to, add a secure registry to your Docker host and let people download only content from that secure registry. So it's sort of what Red Hat provides with the CDN. And if you don't really trust them, then you can do what I said and tell people, hey, you're only going to be able to download images from this registry, or you're only going to be able to download these images from the hub. You can even say now things like you're only going to be able to download trusted images from the hub. I'm not sure what trusted exactly means in the hub, but they give you, there's like a thumbs up icon next to the image in the hub if the Docker company developers, I'm not sure, trust the image. So the need for a kind of a Red Hat CDN for containers becomes really apparent if you care about security. Managing things like the content in your registry. Right now, there is really no solution for staging your images throughout environments. You cannot really say, I want my group of containers to run this image that is in QA, and then I want all of them to update to this other image that is in development. It just doesn't exist. So we are now able to upload images to Catello and Pulp, Docker images, I mean. And with these Docker images, you can basically say, I want these containers to use these Docker images in this content view, which is a concept of Catello that I'm not going to go into, and promote them through your environments. We have a short demo made of the screenshots later, then you can see how this staging your images throughout environments work. You can also do things like multi-container ops that kind of exists with things like Fig or Kubernetes, if you predefine like sets or groups of containers, you can do these kind of multi-container operations like get the logs for this group of machines that do, this group of containers that do X, that turn them off. So, well, that's more or less what Fig provides, but in the Foreman model, so you also get like this unified API, and you also get the role-based access control, and some monitoring like alerts. If things go wrong, if logs match a certain pattern, you can get like alerts. Okay, so what else can go in? There are a bunch of plugins that right now that work with Foreman. There are a lot of work like into getting Kubernetes in Foreman. I'll go through like maybe 4 of the main features that we want to accomplish in the next 6 months or so. But first, let's see how it actually looks like. I'm going just to create a container with an image that I have downloaded that I put into my registry because I know it's secure, and I'm going to stage it from one environment to another. So first thing, you get let's say you have an image already in your Docker host. You just save it into a tar, like Dan said before. This was a source of CVEs in the past. Hopefully, it's fairly secure now. Once you have the tar, I'm doing all of this through the API. Through the API client that we use, the Hammer, which is our CLI, but it can be done through the UI just by going to certain places and uploading the tar yourself. You create a product, which is a way of organizing repositories. So you can say CentOS is a product with a lot of repositories in it. Just a demo product that is called BusyBox, and we create a repository for Docker images. This is going to go to Pulp, this is going to link whatever you put here with Pulp, and I upload the image. In this case, it will be like a very lightweight 5 megabyte image, and then I hope you guys can read that. That's a bad screenshot. So where it says CentOS, it should be like BusyBox, I guess, because that's what I did in the CLI. But essentially, that's kind of a view of what you've put into your Docker repository in Foreman. Once you have that, you can go and create a container and say, I want this CentOS image to be applied to all of these containers. And after a while, you can say, okay, I want this. I'm going to change this image, and I want my containers to run this new image, which is supposed to be more, production ready, and check if it works or not. If it doesn't work, you can go back to that. This is kind of like a list of 3 containers that are running images. You can see very basic things like the UI, the image that is running, the command that you're running on the container, uptime, where is it running. In this case, there's a compute resource called Asus Docker. We're working towards not really linking containers to machines directly, but to say I want this group I want this container to run in this group of machines, and I don't care where. That's on the pipeline. And you can also manage registries. So how does it look? How does the process actually look? You say, I want to deploy my container in a certain compute resource. In this case, it's the machine, this computer. It can be somewhere else. So you can link it to the Unix socket where Docker runs, or you can link it to. You can also link it to URL. After that, you can search for an image in the Docker Hub in an external registry, and if the image that you're looking for is in Catel, you're managing it, you can do all of the things that I said about staging the image, the container through environments, or both actually. In this case, I'm looking for an image that is in the hub. It finds it. And after that, you're supposed to fill some options about the container, like basic things. We try to get stuff from the definition of the image. So if the image requires certain memory, or it has like some C group options, we put these on by default. This is, in my opinion, a little bit complicated. So we're going to provide the ability to have like boilerplates in the future for this. After that, you choose a few options about the environment. I'm not sure why it's not in that screenshot, but you can also set the port bindings. So you can say, I want my container to run, to expose port 80 and make it port 8080 in the Docker host. So after that, you have your machine running, and it's stopped. You turn it on, and you see all of the processes that are running in the machine. Some information, some logs, and what else? Well, if you make some changes to the machine, you can also commit the image and upload it to the hub or to a private registry. And what could be cool maybe is that you make some changes to the BusyBox image. Let's say you SSH into the machine and do something for configuration, then you commit it, and you call that machine BusyBox, development. Go to the previous view that I showed before, and say, okay, so I want BusyBox development to be I want my containers to run that, and it will work like that. Okay. Well, that's just a screenshot with a few more containers. As I said, we really want to group them by functionality. So things that are up and coming are Kubernetes support. Like I said, again, I repeat it, if you're working on anything Kubernetes related, either at Red Hat or outside, I want to know how are you doing it, what use cases you have. Some integration with the Docker host, like we would like to fetch some information from Cockpit. We want, also be able to get advantage of RPM3. You can deploy right now CoreOS things to a community patch, and there will be there was a whole talk at Config Management Camp last Tuesday about this. And yeah, so you want to be able to say, I want a host to be the Kubernetes master, and I want to deploy a container in this host for X or Y, or I want to see what containers are in this host. So more, somehow couple a little bit more the relationship between container and host. Improve the API and the CLI. They're very basic right now. They're role-based access control protected, pluggable via Hammer, and nearly done for all the basic functionalities. And the quick start images, which is an important thing for us. It's like templates or boilerplates of the image and the configuration. So you can just go to Foreman and say, I want to create a new container, sorry, a new service. I want this service to have 10 containers, and I want this 10 containers to run on port X, and I want them to be WordPress. Submit, and it should be done. We have already started to work on this. So think, if you've used Foreman before, you can think of more or less what community templates are, but for images. So community templates, it's a repository for things like like Kickstarts or Jumpstarts, Cloud Config, and all that kind of stuff that our community maintains. If you want to get more information about the tool, you can go to theforeman.org or find us in the Google user groups, Foreman users and Foreman dev, or on Freenode. There are like 300 people at any point in time in any of these channels, so you should be able to get some help. If not, you can contact me directly, I guess. This is our GitHub account where we post all of our projects. The main core is Foreman. And if there are any comments or questions, okay, no comments, no questions. Okay, so all of this. Merci beaucoup, xie, thank you, domo arigatou gozaimasu, dekuye, gracias. That's it.
Why Bronny, by the way?
What?
You probably know my nickname, Why Bronny.
Where?
I asked you many questions in the format regarding the integration I do with Overt. You helped me a lot.
Really?
The discovery image.
Okay. So it was white brown?
Yaniv Brunheim. My nickname is Why Bronny.
Okay, I thought that you were like in the US or something like that, because you asked.
I was.
Okay.
No, I'm from Israel with Ohad Levi, but so I didn't know that you were going to present. I saw your nickname and recognized you. Good to know that you support containers.
What? Okay, thanks. Actually, I thought that only because you asked like questions usually at the same time when people ask questions.
Yeah, I work at night. That's the problem. Tomorrow I'm going to present in the
Okay. Well, you were giving a workshop now. Yeah, right now. Okay. Then. Yeah, I want to go.
Just wanted to say that I'm going to give another lecture also quite the same. Okay. Because I'm going to talk about the discovery image and how do we use it in Overt. So I have like half of my presentation is about Foreman.
Oh, there was.
You stole some of my topics.
Did you go to this one?
No. What? It's something more? No.
Yeah. So that one was about. Well, it was about Foreman API mostly, but the guy made some demo with the discovery, like showing how to discover. Yeah.
Sorry, did you put the slides on that?
I've already put it.
Okay, great. Thank you.
Okay. After that, people always come. Like at Boston, for instance, there was even a guy who wanted to do like something to the plugin and everything, but they ask in private and everything. Yeah, I just wanted to see where the cupcake.
first.
HDMI, VGA, and mini DisplayPort. What does it take?
Oh, I have mini DisplayPort. I also have VGA.
So it's basically the same, I think. So.
Yeah, just don't do it yet. I forgot I have 5 million windows open.
It's best for presentation, right?
Yeah, exactly. And I also haven't connected to it yet. And my presentation is all online, so
Lovely guy.
exactly.
So can you put your online presentation on this offline medium?
No.
Okay.
Well, actually, I pulled a PDF version. I just make sure it's not. The only thing is I didn't really want to distribute it until